the Haber Bosch process, and how it compares to my personal ammonia making methods. The Haber Bosch process is a method of making ammonia in one of the most efficient ways possible. Through the use of temperature, pressure, and catalysts, Fritz Haber and Carl Bosch created a process so essential to humans that we would have likely starved without it. I also handled the task of creating an ammonia equation as efficiently as possible, and once again got the equation N2 plus H2 equals NH3. While I am in no way comparing myself to the genius of Fritz Haber, I am going to compare the two processes, seeing what differences and similarities they hold. But before I do that, I want to take a quick look, I promise it'll be quick, at the fascinating history of the Haber process. Originating in World War II war times, one of the most precious materials was a form of nitrogen that was used in gunpowder and bombs, called saltpeter. The most common way of getting it was through a certain cave system. Unlucky for the Germans, though, those cave systems were occupied by the British and Allied forces, leaving the Germans with the scary sentiment of running out of gunpowder and bombs, a limited amount of firepower. They had to think fast. So they got to work, employing Fritz Haber and Carl Bosch. Together, they created the Haber-Bosch process. Fritz Haber created most of the ammonia-making process, while Carl Bosch optimized it for retail and mass production. The process creates ammonia, which the Germans would then extract the saltpeter from. Although the Germans ended up losing the war, this process would end up becoming one of the most crucial in all of human existence, since the same ingredient that was necessary for the production of bombs and gunpowder was also necessary for fertilizers. And without it, we may have descended into a worldwide famine, killing millions. Back to the Haber process, and how it actually differs from my created process. Features affecting the reaction rate of the Haber process. The Haber process uses three main ways to increase the efficiency of the equation N2 plus H2 equals NH3. These include increasing the temperature, increasing the pressure, and the use of a catalyst. For temperature, most reactions do occur faster at higher temperatures, and in this case, much higher. At around 500 degrees Celsius is where the Haber process is standardly conducted at. The same is true for pressure, conducted at about 200 atm. Finally, the iron catalyst is the last but certainly not the least crucial part of this process. The catalyst lowers the activation energy for this reaction to occur, and oftentimes the iron catalyst is what is heated to 500 degrees, crossing over both the catalyst and the temperature into one. Features affecting my reaction rate for my process. I theorized and concluded two main ways to increase the reaction rate and shift the chemical equilibrium of the creation of ammonia to the right to achieve maximum ammonia. The way I did this was through temperature and adding more reactants. My theory was My theory was about the same as the reason for its use in the Haber process when it comes to temperature, and adding reactants makes the amount of ammonia created to increase. However, this also increased the amount of reactants I would use. Although I would be spending more money, I would also be producing more ammonia. This would not increase the reaction rate, but it would increase the total amount of output of ammonia. Our similarities and our strengths. We both use temperature directly and in the exact same manner. We want to increase the reaction rate without increasing the amount of reactants used. This is a similarity between our methods and a common similarity between a lot of different processes. Increasing temperature almost always will increase a reaction rate. The second factor is a bit of a gray area. I mean the fact that Haber adds a catalyst and I add reactants. This is both a similarity and a difference since we both add a product to the left side of the equation. Mine just does not decrease the amount of activation energy. We had similar trains of thought, however Haber's execution was much better and more efficient and more effective. Speaking of differences, let's talk about some more of them. Our differences and weaknesses, mainly my weaknesses. Time for differences. Firstly, the difference between adding reactants from me, my idea of just adding straight reactants, and his catalyst idea will both increase the reactants for me and decrease the amount of activation energy for him. However, I cannot say the same for mine. Like I said earlier, his is much more efficient. The second difference comes with pressure. Haber conducts his experiments at a much higher pressure, similar to why he does it at a higher temperature. It will increase collisions and reaction rate. I never thought of this, another weakness in my model, and his ideas of adding pressure increases the amount of the efficiency of the reaction without adding any more reactants. That is the dream. Time for the conclusion. I am no Fritz Haber, and I will be the first one to establish that, and his genius speaks for itself. However, it is always fascinating to see how different people think, and to be honest, I am pleased to have even matched the Haber process slightly. Learning about this process, or any process in general, is always useful no matter what. Seeing how common problems get solved can help me apply it to my future experiments to see what I can create. The Haber process, although it's checkered history, is a work of genius, and learning about it, and both Fritz Haber himself, will universally bring applicable lessons to not just me, but probably to everyone.